We're starting a new unit over polynomials. Today we're going to be talking about 3.1, the introduction to polynomials. We have two different learning targets. The first one is to classify polynomial expressions, and then the last one is to add, subtract, multiply, and divide polynomial expressions. That last learning target, we're actually going to break down into a couple different days, just because there's a lot there. We're going to be looking at the add and subtract today. Multiply will be its own, and then divide will be its own day as well, just because those last two can get a little sketchy, and this was probably your first time dividing polynomials, so we need to take some time on that one. So one thing I realized that I should have added in here is you need to know what a polynomial is first before you can classify it. My fault. So a polynomial is a variable with a number exponent greater than 1 or equal to 1, technically 0, and those are integers, so they can't have decimals and they can't be fractions, and then you might have a coefficient. But I'm not as concerned about the coefficient part. So a variable with a number exponent that is greater than 0, and that has to be an integer. So x to the third, x to the power of 4 over 3, that 4 over 3 is not an integer. So that does not work as a polynomial. You could not have x to the power of -1. It's not greater than 0, so it does not work. Okay, so just something to note there on what it is that we're referring to. Okay, so if we're going to talk about polynomials, we need to classify them by the number of terms. So a term is split by an addition sign or a subtraction sign. Monomial is one term. Mono means one. Binomial, 2 terms. Trinomial, 3 terms. So just something to note. Term is separated by a plus or a minus. So, example 1, classify the polynomial, state the degree, and the leading coefficient. So this is in proper standard form. That's something else you need to know. Standard form means that your exponents go in the highest order down, so you're descending in order. So I went x5, x, no x, okay? So looking at this, I have 1, 2, 3 terms, because a term is separated by the plus or minus, right? So I'm separating that there. Three terms is going to be a trinomial. The leading coefficient, this is the highest exponent term, highest exponent term coefficient. Okay, so that is going to be the 4, and the degree, this is your highest exponent, which in our situation is 5. Okay? Don't overthink these, but again, it needs to be in standard form in order for you to kind of have that. We can go through and classify a couple of these when we're adding and subtracting to get a better feel for the classifications. So we only have 4 examples, but I feel like this is something that you've done before. I know that you've done before in Algebra 1, so this should go fairly quickly. When you're adding polynomials, addition of polynomials happens to be the easier one because you're just combining like terms. So if you add, combine like terms. So looking at this first one, x squareds would go together. the x's would go together, and then by default, the 8's by itself. So we have 3 plus 6 to get us 9x squared. So notice when we add polynomials, we do not change the exponent. Okay, can't stress that enough. Now I go with the pink. 8 minus 10 gives me negative 2x. And then that blue is by itself, so plus 8. So if I were to classify this, this is a trinomial, degree 2, and the LC here is 9. And I'm in proper format. My exponents go down in descending order. So we're going to move on to the top right here, because those happen to be the same. If you don't have a highlighter, one way to designate that is just by your underlining and changing how you're underlining stuff. So I have an x cubed, so I have a straight line. I have no other x cubes. I have an x squared. I'm going to make that a dotted line. I have no other x squareds. Now I'm looking for an x. I'm going to give this a zigzag and another zigzag. And then my last one, kind of similar but more of a wave. Okay, so just change up how you're underlining your technique. That kind of helps. If you don't have a highlighter, totally fine. Or on that last one, you can just say anything that doesn't have a line underneath, they go together. Okay, you don't have to underline or highlight. It's just something that helps, I know, to keep stuff organized. If that helps you, by all means do it. If you know what you're doing, you don't have to do it by all means. Do what is best for you. So when I'm combining this, highest exponent term is going to be that x cubed. So I'm going to go with that one first. My x squared. Now my zigzag. I have negative 9 plus 5. So I have negative 4x. And then combine the ones without. So I have 10 minus 12. So I have minus 2. I don't have a classification for this as far as the number of terms. Totally fine. This would be a degree 3 with a leading coefficient of 5. Now, when you are subtracting, the biggest thing with the subtraction that students struggle with is that this negative has to be distributed. Now, what do I mean by that? Here's what I mean by that. This is now going to change to 7x squared minus 8x plus 14. So nothing changed with that first one. That second one, though, it does change. So basically, you're changing the sign of anything inside those parentheses after the subtraction. So it's now minus 8x squared plus 4x minus 19. So all I did was change the sign in front of those in the parentheses, in that second parentheses. Now I do exactly what I did with the adding part. Now I just combine my like terms. So x squareds go together, x's go together, and the no x's go together. So I have 7 minus 8x is going to get me negative 1x squared. Negative 8x plus 4 gives me minus 4x. And then the 14 minus 19 gives me minus 5. This is a trinomial, degree 2, LC of negative 1. So on that last one there, again, distributing that negative to anything inside the parentheses. So AKA just switching the sign. So I'm just going to drop down the first parenthesis, and then the second one, I change my signs. Now I just combine my like terms. So negative x cubed plus 2x squared plus 18x plus 19. So there really wasn't a whole lot to combine there, but that's okay. We're still making sure that we have it in proper order, okay? So my leading coefficient, -1, my degree is 3. And I don't have a fancy terminology for 4 terms. But make sure the negative you transfer to every single component. What ends up happening a lot is students will only distribute the negative to the first term. It's anything inside those parentheses, just rewrite it as a second line and then combine your like terms. Okay, so this is our classification of polynomials. And then on that second learning target, we added and subtracted. Again, we will continue that learning target, but for today, we got those first 2.